Until so far, we've been thinking about the number line as being a one-dimensional object. But what we're going to start doing now is thinking about two infinite number lines and the two-dimensional plane that they create. And we're going to refer to this as the XY plane, or sometimes called the Cartesian plane. So for number one, before we actually get into doing any of these problems, for number one, you'll see this two-dimensional graph. So we have one horizontal number line right about here, and one vertical number line. It's basically two copies of the same number line. But now, since we're dealing with two variables, one of these is going to be denoting the x variable and one the y variable. So from here on out, and this is always the same, this never changes, the horizontal axis is the number line that represents the x variable, and the vertical number line is the number line that represents the y variable. Now, if we look at this two-dimensional plane, well, this is different than, let's say, the number line, because if we're just looking at, let's say, a number line, every number is located on that line. If I said, where's the number 3? You would say 3 spaces to the right, and right here is the number 3. But now we have, so let me erase this because we're going to need some space. So now we have these two number lines, but there's also all of this space over here, and also over here, and here, and here. So we have to be able to sort of describe locations on this two-dimensional plane. And we do that with these ordered pairs. Ordered pairs, or we could refer to them as points. The location of points. And so any place or any position on the xy plane has to be described by two numbers. And we're going to use those two numbers relative to the center. And we call this the origin. The origin, that's that right there, that's the point 0, 0. That's our point of reference. It's 0 on the horizontal axis and also 0 on the vertical axis. And in this particular diagram, both the horizontal and the vertical axes go out to 10 units in either direction. So this would be -5, -10, +5, +10, -5, -10. All right, so for number one, plot the ordered pairs on the rectangular coordinate system provided and determine the quadrant each point is located in. All right, well, let's look at this first point. Let's use blue for point A. So this is the point 3, 4. So each ordered pair is given as two numbers. The first number is always the x value, and the second number is always the y value. So for point A, which is the point 3, 4, this is saying 3 on the x-axis and 4 on the y-axis. So we go 1, 2, 3 units in the positive direction on the x-axis because it's +3, and 4 units, 1, 2, 3, 4, 4 units on the y-axis. So 3 units to the right and then 4 units up will put us right here. And this would be the point 3, 4. It's a location. Now, right now, a point or an ordered pair is just a location. It's a place on the xy plane. Later, these ordered pairs are going to have more meaning when we start talking about them in terms of equations. But for right now, if it's just a generic point, there's no equation attached to it, a point or an ordered pair is a location on the xy plane. Now let's look at point number 2, or the point B. So let's use green for this one. So that's -6 for the x and positive 3 for the y. So we're going 6 units in the negative direction for the x and 3 units in the positive direction for the y. And so that will put us right here. So this would be the point -6, comma, positive 3, or x equals -6, y equals positive 3. You see, we're here at -6 on the horizontal axis. We're here at positive 3 on the vertical axis. And this last point, point C, let's do this in red. Well, that's -1, -3. So actually, let me get rid of this because it's sort of in the way of what we're about to do. Let's change this point to black. Origin is the point 0, 0. And that's that point. Okay, so -1 in the x direction and -3 in the y direction. So that will put us right here on the xy plane, -1, comma, -3. Okay, and now the second part of the question is determine what quadrant each point is located in. So this word quadrant, well, if you look at this two-dimensional plane, it's cut up into 4 pieces: upper right, upper left, bottom right, bottom left, and it's cut up by the axes. So the x-axis horizontal, the y-axis vertical. And what we do is we start with the upper right and we count counterclockwise. So the upper right quarter, or the upper right quadrant, we call that quadrant 1. And then the upper left, where x is negative but y is positive, we call that quadrant 2. The lower left, where x and y are both negative, we call that quadrant 3. And the lower right, where x is positive and y is negative, we call this quadrant 4. And they're normally given as Roman numerals. It's just the standard notation. All right, so it looks like point A, the blue one, is in quadrant 1. Point B, the green one, is in quadrant 2. And point C, the red one, is in quadrant 3. All right, so in this first problem, you're given points and you have to label them. In problem 2, sort of the opposite. You're given the points on the graph and you need to find the coordinates. All right, so point A looks like it's right here on the x-axis and right here on the y-axis. And just like the last problem, each little square is 1 unit. So this would be 5 units. This would be 10 units. -5 would be here. -10, and so on. So this would be +5, +10, -5, -10. This would be the origin, 0, 0. So it looks like point A is 2 units to the right, so +2 all for the x-axis, and 4 units up. So point A, let's make this one red. A is the point 2, 4. All right, point B. Let's do point B in green. So for point B, it looks like we're here at 9 on the 9 units to the left on the horizontal or the x-axis. So that would be -9 for the x value, and it looks like we're here at +1 vertically. So the horizontal value is -9, and the vertical value, or the y value, is +1. All right, and finally, point C. Looks like we are at positive 5 on the x-axis. And vertically, we're down 5, so negative 5 on the y-axis. Let me make that 5 look a little bit better. Positive 5, negative 5. All right, so those are the locations or the coordinates of those 3 given points. Okay, so for these first 2 problems, these just generic points are just nothing more than locations on the xy plane. Now, for number 3, determine whether the given ordered pair is a solution to the equation. So now, when there's an equation attached to the point or attached to the ordered pair, an ordered pair can be a solution to an equation. So for this first one, we're saying x equals 2, y equals 4. That's the point, 2 comma 4. Now, is that a solution to the equation? Well, we have 2x plus y is equal to 8. So does this x value and this y value, so if we take these 2 values and plug them in, so replace the x with the number 2 and replace the y with the number 4. So 2 times x is now 2 times 2, plus y, which is now plus 4. Is that equal to 8? And actually, we're still questioning this. It's a yes/no question. Is this true? Well, it's a solution if it gives you a true statement. And 2 times 2 is 4. 4 plus 4 is 8. 8 equals 8. Check. That's correct. So the answer is yes. The point 2 comma 4 is a solution to the equation 2x plus y is equal to 8. So for that first one, the answer is yes. Let's look at the second one. Well, x is equal to 4, y is equal to 4. That's the point, or the ordered pair, 4 comma 4. And let's plug this into the given equation. 4 times x minus 3 times y is equal to 28. Well, replace the x with the number 4 and replace the y with the number 4. So 4 times 4 instead of 4 times x, and 3 times 4 instead of 3 times y. And again, this is still question mark. Is this equal yes or no? So 4 times 4 is 16. 3 times 4 is 12. And if we take 16 minus 12, we get 4. So we get the statement 4 is equal to 28. Well, is 4 equal to 28? No, absolutely not. 4 and 28 are 2 different numbers. So 4 equals 28. That is a false statement. So no, that's not true. So we would say no. The ordered pair 4 comma 4 is not a solution to the equation, should be 4x minus 3y equals 28. So yes for the first question, no for the second question. All right. That does it for this video. I'm going to do the other, I think there's 4 more problems on this worksheet. I'm going to put them on a second video, but my recommendation is as soon as this video is over, please watch the next video covering the remaining questions on the worksheet. Okay, that's it for now. I hope this was helpful.